All right, now the first thing that we did with the limits, we had limits as x approaches c, where c was an element of real number. So in other words,
Yes.
the x value was numerical. We needed to just substitute into the equation and get the limits. But if we had something like rational or fraction, we were supposed to be extra careful with the denominator. You test out the denominator, it shouldn't be 0 when you substitute. But if it becomes 0, you're going to have to factorize numerator and or denominator. And then you cancel out, then you substitute, then you win. Are we good? All right. Then thereafter, those were basically algebraic equations. Then we went to trigonometry. In the trigonometry, we needed to remember two rules. Sine of theta all over theta. As theta approaches 0, the answer is 1. Even if you were to flip the equation, if you flip the equation, theta over sine theta, the answer will still be 1. Then, remember that everything is in radian. Then cos of theta, when theta approaches 0, it's also 1. And you can write that equation upside down. We good, right?
Yes.
Then, remember, I'm talking about the trick. Then, if they were to give you x approaches, because there was another example, but I haven't done it, but I'll clarify some later. Let's say we make it approaches 3 with the trigonometry. We would be saying, now, wait a minute, that can be right because the x must approach 0. So what will we do? We actually transpose to the other side here. Am I right?
Yes.
Right. In other words, the arrow is behaving like an equal sign. So you would have x minus 3 approaches 0 or equals to 0. Then we are happy because we now have the 0 here on the right-hand side. So x minus 3, we can now give it a new letter. Let's call it theta. That means in the question itself, you'll be able to identify x minus 3 and replace it by theta. We good?
Yes.
Yeah.
Yes.
And then because you would have actually written it like this, theta equals to x minus 3. That means you can also solve for x here because you have to replace the x by something that has a theta. You would have brought the 3 here, meaning x is the same as theta plus the 3. So what am I saying? I'm saying, number 1, x minus 3 will be replaced by theta, but the x alone will be replaced by theta plus 3. Then we apply that rule for sine and cos. For sine and cos. All right. The one that give us 1. Good. We happy, right?
Yes.
All right. Yeah, there is another rule where you have to flip, but it's coming in when we're doing infinity, because now we are going to go for limits as x approaches either positive or negative infinity. That will include also what we call absolute values or modulus. I think you know absolute values or modulus. Am I right?
Yeah.
Okay, good. So that's video number 1.